When it comes to quality, which is undoubtedly an important component for being competitive, managers are concerned with mainly two questions. Do we deliver the quality that our customers expect? And how can we improve the quality of our goods or services? To address these issues, organizations need to manage quality using a three-step process that is similar to managing other business activities, such as managing financials, namely, to plan for, control, and improve quality. Our focus today is on control, making sure that the product or service meets customers' expectations and standards. The managerial process of control includes measurements and evaluation of actual performance, comparing performance with standards, and taking actions to correct any diversions from the established standards. Customers expect a consistent experience. For example, when you go to a restaurant, you expect not only tasty food, you also expect the order to be accurate, that all meals will come to the table at the same time, that the served meals will be at the right temperature, not too hot, not too cold, and so forth. If you are happy with the experience, you will come again and you will expect a similar dining experience. From a management perspective, this means that the process needs to be controlled so that throughout time the process is stable and keeps meeting customers' expectations. That being said, we know that nothing remains constant. Consider the example of getting ready for work in the morning. You probably have a routine that works most of the time, but some days can be very hectic. Whether your alarm clock did not go off, or the coffee machine broke and the coffee spilled all over the kitchen floor, or there was a construction project that started that day on the highway when you went to work. We all have our own war stories for hectic mornings that most probably resulting in being late to work or getting a ticket on the way. The above reasons for being late to work were caused by an unexpected events that are not part of your regular process of getting ready to work in the morning. This is what we call special causes of variation. On the other hand, there is variation that is inherent to the system. For example, if it is a regular morning and there's no construction project going on the highway, then your driving time will vary due to the traffic patterns that are the regular traffic patterns of a morning rush hour. In other words, managers need to be able to differentiate between common variation and assignable variation. Common variation is the random variation that is inherent in the system or the process. It might be difficult to identify the causes of this variation, and to the large extent, the degree of variation is minor. Reducing common variation usually requires management intervention and may require investment in capital. For example, to buy a new machine, change vendor, or redesign the process. Special causes of variation is not inherent in the system. It occurs when something changed in the established process itself, like a machine that breaks down, or an employee who doesn't feel well. By monitoring the process, these root causes of assignable variation can be identified and removed, or at least reduced. A process that exhibits special cause of variation is said to be out of control or unstable. Addressing assignable causes returns the process to its normal variability, which is determined by the common cause of variation. When process is stable and predictable, only common cause of variation is present. A technique that enables managers to identify, control, and reduce variation is called statistical process control. It is based on statistical theories which are mostly beyond the scope of this course. One of the tools that we will use are control charts. These charts provide visuals for discovering informative patterns and signal that present special causes of variation. Let's look at a control chart for a process of filling up cups with 6 ounces of yogurt. Throughout time, the weights of yogurt cups are recorded and depicted in a chart. The control chart is basically a run chart with 2 additional horizontal lines, which are the red lines and are called control limits. The green line represents the average weight of the current process. The control limits are chosen statistically to provide a high probability for a process that is stable and in control. The points will fall between the lower and upper control limits. Typically, the control limits are 3 standard deviations from the average of the process. If points fall within the control limits, then there is no pattern over time, then there is no indication of special cause of variation, and any variation is due to common causes alone. On the other hand, points that fall outside of the control limits or follow a pattern within the limits indicate that the process is out of control due to special causes, and correction action can be taken. The distribution of measurements of the process output over time is called the voice of the process. It is important to realize that control limits are determined by the voice and the ability of the process, not the customer's requirements. The customer requirements are defined as specification limits, which are different than control limits and will be discussed in a different video. Let's look for an example of measuring thickness of lens, say for the glass of the car windshield. In addition to a scatter plot, we can examine also the distribution of the glass thickness via a histogram. The mean of this process is 8.0008. It is represented by the green line. The control limits are determined as 3 standard deviations above and below the green line center. In this case, the upper control limit is 8.050 and the lower limit is 7.95. By adding a line that connects the point, we get a control chart. To be predictable, a process must be in control. An obvious sign of out of control is an observation outside the limits of 3 standard deviations above or below the average. Other signs can provide early warnings that the process is over or about to go out of control. A set of rules had been developed to provide early warnings of an out-of-control situation. The term out of control is used when the rule has been violated. In this example, we see that there is a point that is just beyond the upper control limit. This variation might be due to a sudden event, but it might also be a result of a measurement error or an error in calculating the control limits. Runs occur when points continually appear on one side of the center line. The number of points is called a run. In this case, we have a run of 9 points and a run of 10 points. Trends occur when there is an upward or downward increase in consecutive points. A cycle occurs when there's a repeated pattern. When most points are within 1.5 standard deviations from the center line, we say that the process is hugging the center line. For each of the following charts, we will examine the example of whether the process is in control or no. In the first control chart, we see that there are 2 points outside the upper control limit. Perhaps a machine needed to be reset or fixed, or a new employee is operating the process and she needs more training. These issues can be addressed at the workplace by the employees who are operating the process. In the second control chart, all points fall within the control limits, and there does not appear to be any pattern within the limits, so we can say that the process is in control. Any variation in process is due to the common variation which can be addressed by management, as they will need to redesign the process or the product, and if there's a financial or other justification to do so. In the third control charts, all points fall within the control limits. However, midway, right here, there is a trend that the points fall above the center line, indicated that the mean might have shifted upward, maybe due to deterioration of the machine. Employees should take action and correct this variation. Otherwise, the trend will most likely continue, which will result in a process being out of control and products being deemed defective. In the next video, we will examine how control charts are generated and how they can detect inconsistency in the mean or the spread of the process. And in the following video, we will look at specification limits that are the requirements of the customer. Thank you.